Yeah.
Thank you.
I don't know how long we should wait, James.
It's been 5 minutes.
Mhm.
Yeah, I'm gonna start real slow, so might as well get going. Yeah, so ladies, thanks for joining me. Yeah, so this is our National Engineering Month event for East Toronto chapter. This one is focused mostly on our education as and STEM event, as that's the role I play at the board. So for myself, I'll just introduce myself. I'm James Tate, I'm PEng. I'm a mechanical engineer and I work in the elevator device industry. And I've been a volunteer for the chapter for about 5 years. Been education outreach for this year and the previous year. So this year's a great opportunity. We had a plan for an event last year, but plans had to be canceled just due to the situation. So this year, as we're doing this event all Zoom based, we had some time to plan and sort of, you know, be part of this big month of tons of events. So I'm just gonna mute that. Yeah, so we're gonna just keep going here. So just quick agenda on what we're doing today. So this is technically to be a future engineer career seminar. So we're gonna sort of talk about some stuff, talk about engineering topics, and then hopefully you know maintain interest in STEM topics and engineering going forward. So yeah, those are the first two items, and then we're gonna have a creative problem solving activity. I figured that would be sort of interactive, a little bit educational, sort of be discussing as we go, and then at the end there's the opportunity to sort of show off what you're doing. And if you don't have to turn your camera on, that's not what we're talking about, but yeah, I'm gonna have a form we can fill, and then as part of the organization there'll be a poll at the end. So anybody who wants to take part in the poll or fill out our interactive form, that'll be it at the end. Okay, so as for introduction, I'm gonna just start rolling in. So if you're with us, you're probably familiar with STEM. I'll put a little graphic up here just to kind of go through quick. Obviously, the acronym stands for Science, Technology, Engineering, Mathematics. And for us engineers, we sort of look at the other three as part of the role, right? Engineering involves those three things, and all this is sort of a symbiotic thing. So yeah, today we're going to get into a little bit of math, a little bit of science. The technology is going to be really low tech though. Aside from this, wonderful Zoom technology we have, the technology in this event is going to be a little minimal. Until the end, there'll be a little bit of fun stuff. But yeah, this is ideally to be interactive and a little bit of a discussion, question, answer kind of based. All right, so I'll put together a couple of things, my thoughts on this. So engineering career for me, I like to go through the whys, hows, and whats of a lot of topics. So the why that I put down is sort of like why engineering is a career would be to improve society and using knowledge and experience. So engineers obviously know that we gain knowledge for all our years of education and study, and then we gain experience doing all sorts of things. Projects in different levels of school, through university, after the fact, when you get you're into the workforce, take on lots of projects to gain lots of experience, and all that helps us to really know how to be an engineer and be involved. So the how is obviously I mentioned before, like we use the full element of the STEM acronym, right? You're doing ingenuity with all those topics, the science, technology, and math, and of course engineering is kind of the centerpiece on our side. And the primary thing there is to solve problems. The world's got lots of problems, and if you like solving them, that's probably a great opportunity to be as a career path to be an engineer, because you're going to be faced with problems of different scales and sizes every day. And then like what do we do? So solutions for enhancing everything needs to meet is what I think about it. So sometimes you have a problem and you need to find solutions, but sometimes the solution you need is just about enhancing something. So I had a junior professor tell me one time that all the fun jobs all the fun things have already been invented, and now it's just a matter of making them better and better, more optimized, things like that. So I think for me that's a big part of engineering as a career. So now we're gonna get into the fun stuff. So what we'll do today, right? So we're going to examine, experiment, creating buildings and bridges and towers. So obviously very traditional structures that you would associate with engineering specifically. There's architectural elements to these things, of course, but as structures, they're more related to the engineering work than the aesthetics of a building like architectural would be. So I got two sort of different cases here. I got a nice little simple graphic of a bridge to kind of explain, you know, one of the key elements of what we're going to do today is shapes, geometry. And with almost every bridge, you're going to see a plethora of triangles, different scales, and they're made of all kinds of different materials, of course. And on the other side, we have the CN Tower, which, of course, for me is close by. I live in Toronto, and I'm sure you guys are familiar, or being from Ontario, you obviously know CN Tower. It's a huge landmark in Canada, has been for a long time, and it was definitely a really big engineering achievement for the country a long time ago to really show our ability nationally as well. And it stood as the tallest building in the world for a very long time, which also emphasizes the achievement. So what we're going to do is we're going to look at some of these things in the different ways and simplistic versions of what's sort of some of the simple math behind the geometry and things like that, and then how can we actually achieve some of these ideas and play around with it, make it fun at least. So if you saw in their email blast, I included some little images similar to this one. So the deal is like, how do we make these connections, or how do we make these structures? Well, the basics idea of like a bridge especially, or a tower. CN Tower is a little different. It's more of a concrete structure, but there's obviously structural elements at the top and all these other things. But we want to build a structure, and we're going to be, the first thing that you kind of do is you learn to build things with things you're familiar with. As you get more involved at a later state, doing different kinds of problems in school, or especially in university, you learn a lot about the materials and the different things that engineers sort of had at their disposal to build structure and solve problems. And they're a lot bigger and harder to work with than something as simple as pasta or marshmallow. So I know that we have a couple of people with us. I'm hoping if you saw the email blast, you came slightly prepared, because it will be more fun to be interactive, or else you'll be watching me with my hands kind of doing some of these. And, I did a few early on when I was planning the event to kind of see, okay, so how far can I really push these things, right? So the deal is too that, with engineering, we're trying to solve problems, open-ended problems. Sometimes you don't really know what the solution is, but you know that there can be a solution. And with this stuff, it's sort of like, well, what could you do with, marshmallows and pasta, or there's some other options I threw out, which I'm going to play with today. Candies, or steal little hair bar pins, things like that. So if you start with something simple, like you think, well, what can this do? But realistically, you can do a lot. It just depends on how you use them and what you can actually make of it. So we're going to use these simple materials readily available. Hopefully you have some nearby to make some shapes and start to work with those shapes and figure out how far we can push these to make some pretty drastic solutions. So I kind of always think about, when we get proposed a problem, or someone says I need a solution, they're basically helping you set the goal. What do I want? Somebody knows they want something, and so you try to help understand them. You kind of talk to your people that you would work with, or customer, things like that, and they sort of give you an idea. But really, you're the one to set the goal and say, like, this is what we actually need to achieve. So I'm talking about, small scale things at, your fingertips, and you have some saying, well, maybe there's nothing you really need to achieve, but we're also trying to have a little bit of fun. So why not challenge yourself and say, hey, I've got 2 chairs. If I stick them a certain distance apart, can I build a bridge across that? Maybe that's not the thing you want. Maybe you're more interested in the tower idea. Well, you got a table or something? Yeah, could I build, like, this simple materials? Could I build a tower that's as tall as that? Because at first you say, well, yeah, sure, just stick the pieces together, but as we'll soon find out, it's not that simple when you really get into it. So the thing for me was like, I was like, yeah, I'll start with a bridge. I like bridges. They're interesting, a lot of triangles and things like that. So I set this out to, sorry for this North American measuring tape, but it's only in inches. So I set it out to about 200 millimeter, 20 centimeter. and said, yeah, I'll build a little bridge over there. And I'm going to even challenge myself to try to put some weight on it, see if I can make these simple materials hold up weight, just like in the real world. We need to make a bridge that can actually carry the weight of the people or the cargo or the vehicles or whatever is going across it. So, all right, so I'm going to pass this slide. So, all right, tools and materials. These are kind of the basics. Engineering, obviously, there's the designs elements, and we're not really going to get into that too much today because design is just a very vast thing. But we're trying to have some fun and be practical. So I gave these lists in our email. Some suggested materials, and I break them down into kind of 3 sections: members, connections, and your measuring methods. Right. So I got again my American measuring tape in inches, not in metric. And then I have, a selection of materials. So the previous picture I showed, excuse me, pasta is my members. And I said slender pasta because, if you use penne or something, it's going to take a lot of connections and it's not very efficient. So I said, slender pasta is good, spaghetti or thicker is better actually. And from one of my classic inspirations, I think bobby pins is a fun one. And you could probably use even like cotton swabs or something, just something that will allow things to stick together. And sorry, cotton swabs. I'm thinking of what's the other one? Cotton balls, not cotton swabs. Cotton swabs are the ones with on the ends. And then toothpicks, kind of small. That's kind of a small scale one, and that would be cool because maybe you could do something that looks really interesting, but it's actually small scale. And of course, the stuff's all going to be small scale. And then your connections are kind of interesting bit. What you stick together. Marshmallows. I'm going to use gumdrop jujubes. I'm a big fan of candy. So yeah, I want to see, I'll use something sweet and probably eat a few on the way. You can eat a marshmallow. If you pick cotton balls, yeah, not so much. And yeah, the measuring style thing is to, we want to set our goal. We got to actually know what we're aiming for, either on height or things. So maybe you only have so much material. Like I bought a nice bag of them, but I don't know if I'm going to have enough to build a tower 1 meter high. So it's good to kind of get an idea of when we start building a couple of pieces, how far we can take it. So I'm going to go on to the next slide. So this is where I'm going to say, if you do have materials in front of you, let's start doing a little bit. So I got some, sorry, I think it's on the floor, but I got some candies and some marshmallows. So I'm going to crack these open. I already sort of prepared a piece for myself. Oops, didn't go that far. And I think we should start with something really simple, right? Just to get familiar with what you have in your hands. And that's really an important part of learning engineering is getting familiar with what you're working with. And I'm going to pry open some of these candies, right? And when I made my previous one with marshmallows and pasta, I run into some interesting challenges. Which I got around, of course. That's part of engineering. You have to, you learn a little bit, run into challenges, and either you learn from that and you can move on, or you maybe find a different option. So in the first case I gave, I'm using marshmallow and pasta. Now I'm going to use candy, and it's hard to see, I know, but a bobby pin, right? You might have some of these at home. Your hair, I don't really use them for my hair, but. Anyway, so yeah, I'm just gonna basically put the points across and say, hey, I want to make a triangle. So I'm just gonna start sticking these together, real simple. And I'm gonna make a triangle.
You hug me at the most inopportune time. Yeah. I know, that's what I'm saying.
All right, so everybody knows triangles, right? And the other shape I have up here is prism, right? So triangle is obviously 2D, and I drew equilateral triangle just because. If I'm picking a standard piece of something that's the same length, I'm going to need a triangle that's get equal lengths. But everybody knows that, there are lots of kinds of triangles, and right angle triangle, the guy with the little square is a very popular one, right? So as I go here, I may have to make some square corner triangles. So I'm going to just feed this one in. I know it's kind of hard to see what I'm doing, so I'm going to try to put my hands a little bit better. So I've got a couple of steps here, and I got one more connection point and one more candy to go before I have my triangle. So everybody following so far? And is anybody going to be able to follow along and try to make some shapes with me? I'd like to get some feedback so far. Anybody want to chime in? All right. So, all right.
Unfortunately, James, I don't have anything that I can use.
That's okay. Maybe you should comment on what I'm doing and see if you have anything
Yeah.
to add, Larissa. Like, as we were talking transportation before, you're a transportation engineer. I'm sure you have to deal with bridges and things, but maybe not exactly how they're built. Maybe you do.
Mm-hmm.
But you don't. Oh, guess marshmallow. I forgot. Marshmallow's a bad one, right? Maybe some of these can't. What would be a vegan solution? That's a good point in there.
Well, you have vegan gummies,
Yeah, that's
like,
it, right?
yeah, it's just that instead of pork, they use a different material, soy-based material, like
So that's a really good point, right? So if you're using something that's maybe more sustainable as well, rather than these days, obviously that's a big topic, and engineering, of course, sustainability is a big factor. So maybe I should have been a little bit more forward thinking and said, maybe if I want to use candy, I should get some vegan, sustainable candy rather than these bad ones that I got, right? But
okay.
so anyway, anyone else? Does anyone have materials with them? And we have Anna or Nara. Anyone there? Did you come prepared, or did you come just to watch me fumble about with these candies?
Yeah, I have marshmallows and pasta
And toothpicks.
and some toothpicks.
Toothpicks. All right. So yeah, marshmallows. So if it depends on what kind of marshmallow you have, right? So I bought some of these little ones, and before I use really big ones. So yeah, if you use the small ones, they're a little bit trickier, but really the big ones are kind of overkill anyway. So yeah, so let's start. I'm sure you can build a triangle just like I have really easily, right? So things start simple, right? The whole point of this is to say, like, we're looking at really simple shapes here, and all these big projects, they start with like simple, relatively simple ideas, but we obviously expand them to quite an extent to do things as tall as the CN Tower or bridges as long as they are cut today, right? So let me jump one level ahead because I've made my nice little triangle, and I'm really proud. But like I said, the next piece is sort of the 3D aspect, right? We live 3D world, so the prism is sort of the regular evolution of a triangle, right? It's essentially two triangles within some sections in between. So I normally think of them as solids, but in this case, if I keep going and make another triangle and I make connections between these two triangles, I will have a prism. And that prism could technically be considered a small structure, or it could be the beginning of something bigger. If you take this prism that's on the screen and you imagine it goes up real tall, you're actually going to see something that's similar to the CN Tower. So that's one of the ways to take this. You could say, hey, if I keep building my prism taller and taller, eventually I'm going to have a tower. Or if I was to make maybe different shapes, we could get into something that's going to extend in long length. Maybe that's something more like a bridge. So if you have any preference, I'd say maybe make a choice now and either go to say, hey, maybe I want to pursue like a tower style design, or maybe I want to pursue bridge style design, right? So I'll skip ahead a slide and we'll get into the idea that really helps to make a bridge, right? So before I showed the the animated bridge, lots of triangles, and this is the more simple, less complicated piece of that, which is sort of like your basic truss, which is made of, you can tell, 3 triangles, right? And 3 triangles, but not using the material 3 triangles. We're starting to save material by sharing pieces from one to another. So if I was to continue, this is where this event starts to get a little bit fun. It's going to take me a minute, right? And that's sort of analogous to how all these projects go in real life, right? You can imagine what you want to do, but actually doing it takes quite a bit of time. It takes people to do the jobs to actually get it there. After, if you're an engineer, you can understand what you want and you can spend time designing it, but then sometimes design doesn't take nearly as long as building, or Maybe it's the other way around. You know, sometimes design can take a very long time. So I'm gonna just push my jujube triangle into a truss for now. Actually, you know what? No, I'm obsessed with trusses. I'm gonna build a prism. I'm gonna try to build a multi-prism.
Oh yeah. Time for your snack.
You have anyone else join the meeting? So next thing, sorry, I can't do it on camera. I have to put pressure on these guys. So I've got a couple more. Let's see. I'm gonna have a little music background. Okay. Patience is key with this stuff. So, sorry, I couldn't tell who said they had pasta. So one of you, was it Anna or Anara that has marshmallows and pasta?
I have the marshmallows.
Okay, so what do you think? You're gonna try to make a truss, or you're gonna go with tower?
I think I'm gonna make a bridge.
You're gonna make a bridge. All right, so you're looking at the truss idea, right? Do you have any idea of how big your bridge is gonna be?
I don't know. I'll see how big I can get it, I think.
See, that's the risky part, because if you'll start and then you'll realize, oh, this actually takes some time. Because I've been doing this the whole time I'm talking, right? And it just took me a few minutes to get simple prism, right? And truss is 2D, right? That's if I jump back to a couple, right? Like kind of like this one, you know, that's not very, that's not a lot of members or connections, but it takes a minute, but you'll build that fast. The next part will be, if you consider like, okay, I got a 2D truss and then I want to make it actually a bridge. Well, this truss won't stand by itself, right? It needs to be sort of turned from a 2D to a 3D shape. That's kind of why I'm saying, hey, let's look at a prism, right? That's a good 3D shape that kind of gives, it can stand up by itself. It can take a little pressure, a little weight. Nothing crazy yet. Of course, it's pretty small. But as you go with your simple 2D truss and you keep going, you know, it will get stronger over time with more and more sections. So if I built my little, say, first thing I'm gonna do, I'm gonna actually start leveling it out, because one of the critical things with this is you can start building, and I've been just sort of building quickly. And I've already noticed it's kind of out of line. So I'm gonna spend a little bit of time here just to try to get it back in alignment a little bit, so I have a opportunity to keep going and not get out of balance too early. So I'm just gonna straighten these things out, and then I'm gonna have the basis of my truss, basis of my triangle prism foundation. So yeah, now it's time to go on one more level. And I picked all orange, right? But I'm gonna change it up. I'm gonna make layers. I like to see the CN tower with lights. You know, they have the lights that go up and down sometimes. So might as well make my tower vary in color. So if you're going the bridge route, I made some examples, like you know, to see what, okay, well, it's important to know like how many pieces and things you're gonna need, right? So I assume if you have marshmallows, if you have small or big, you probably have a good volume, right? But as we go through, you're gonna realize, okay, well, do I even have enough? And part of that comes down to, well, how big are you trying to make your bridge? How many pieces am I gonna need? How much pasta am I gonna need? And what kind of sections, right? So because I'm using bobby pins, and I've pre-made this one, I've chosen all the same size lengths of members. But if you're using pasta, you have some flexibility, because you can say, oh, I want different lengths, which is very common, right? Not everything is built out of the same scale members, and connections are all different. But in this case, because you have pasta, you can play with the length a little bit if you want to make non-equilateral triangles or right angle triangles, or, you know, there's obviously the square factor, but, you know, there's some benefits to using triangles. Even this bridge, in this little truss here that I've got, I can make this twist real easy. But, you know, if I turn it into a triangle, if I add one more pin, I can get some stability there. The only problem is because I made a square, now my thing doesn't fit, right? So if you're using pasta, it's a good option where you could use some members around the same size for the squares and the triangles. But then if you need to cross section some of these things, make them a little bit stronger in the bottom here, so you can use a longer section. That's where pasta is going to be a nice option to build different things versus what I'm trying to do here, or what I've done here is make something that's real simple and symmetric. So I've got my original truss I made ahead of time because I was like, geez, I don't know how long I'm gonna have on the camera. So I made this one, it took me about 10 minutes, and then I made this one as I'm talking to you guys. But I could easily continue and make this even longer bridge and say, hey, like, have I met my goal yet? Because I remember I set a goal in the first place, right? I said, let's see if I can build something that's gonna reach 20 centimeters. So these little guys, these short little steel guys are strong, but they're not very long. So, and of course they're strong because they're made of steel versus pasta, not so strong. But the trick here with this is the more pieces and segments you use, the more dynamic or diverse the structure is, and it starts to support itself in different ways. So the more you experiment with the materials you have and different sizes, and do I make these members shorter or longer? Shorter or longer is going to be stronger or weaker, and that's really critical when you're looking at these different structures. So halfway through, now you're working on yours. How far have you made it? Have you made what I call like a simple 3D truss yet, which is based on 10 connections, and I think I counted 14 members? That does take some time. Maybe you're surprising me and you're far ahead of me. Maybe you're faster building than I am. I'm going to keep going on my tower because it's only one segment high so far. Just give me a moment there. Maybe get into more candies. And I may have to also look at how my tower is going, because right now I'm like, it seems firm, but it could be a little more firm, or maybe I need a little bit wider of a base. So I may have to play around with that a little bit before I go on to the next phase. But for now, I'm like, yeah, I think this is going well. So I'm going to keep going and try to gain some more height with these fabulous candies and steel beams. Well, they're not really beams, of course, but they're analogous to beams. Let's see. So I'm going to keep rolling. Keep flowing. So again, I haven't set a height goal for myself, but I can kind of get an idea where I'm going here, because after I do my third level, I'm going to get an idea of how many levels it would take to get to a certain height. That's part of understanding the shapes that we're making here and what we have with the materials we have. So because I have fixed length members, like I said, the pasta is a little bit more of a optional member. It's kind of like wood. Wood, you start with something, you can cut it down to a specific size. But with these guys, I got to sort of fit it at already a size, and I can't really work with that. I can't really change it. So I'm going to just make my triangle connection at the third level, just to make it to a measurable height. And then I'm going to see how far or how many more of these I would need to get to some sort of height that I think is substantial. All right, so let's see. All right, so double prism, but still a prism really. And it's still pretty stable, but I can feel it's going to start to wobble a bit. Again, I can try to straighten it more, but it still probably needs something extra to kind of make it a little bit more stable. But what I was going to talk about with the measuring thing is, measuring is really critical in any engineering work. You got to know what you're measuring. And we talk about all kinds of things, I'm talking about simple geometry things here, but measurable things in engineering is very vast. It could be speed or weight, or the number of cars going over a bridge in a day, or, there's a lot of different things, right? So this to be like, what's something that's tangible that we can talk about? I'm going to pick my little double layer prism here, and I'm going to take a quick measurement and see how far I've gotten. So again, forgive my tape. And I'm just about a 100 millimeters. So if I said, I think I want to take this to a meter, so then I'd have to multiply this by 10. So if I want to do this again times 10, first thing I need to know is like, do I have enough material to do that? Because it's easy enough to say, oh yeah, a meter, but if I'm looking at what I'm making, have I really come to the construction site with enough material to actually get there? And that's one big thing, right? So I'm now saying, okay, well, I could repeat this 10 more times, and I've used 9 jujubes. So if I want to repeat it, I'm actually going to get to not have to repeat them all, but and there would be a way that you could calculate that, and you can add it up and say, oh, I want to do this so many times, and I've got to consider that I'm not going to have to use the same 3 top ones again. So every, if I want to go another 100 millimeters, I can save myself 3, but I'm going to need 6 more. So realistically, I'm going to say, to go 10 millimeters, I need 6 more each time. And if I want to go that, okay, so I need 6 more 10 times. That's 60. And I don't know if I have 60 jujubes. That would be the question. So maybe I have to set a more realistic goal for what I'm trying to achieve and understanding what I have and what I can build. So if I want to go a bit further, yeah, I could just keep going with the ones I have in my little baggie here. And if I count the quick, I can get an idea of how far I'm going to be able to go. So next part of this is, if I count my baggie here really quick, I'm going to go 4, 5, 7, 10, 11, 12. Well, it seems I only have enough to go another 2 more sections of what I built. So I can extend this double, and that should take me to 300 millimeters, pretty far off from a meter. So I need to get more materials if I want to keep going. And I probably am going to need more steel sections as well, because I'm also running a little low on those. So if you've got a packet of pasta, I don't think that's going to be a problem. So maybe I should change my tactics and pick something that I have a lot of and something that's a little bit more flexible. As well, I could probably do with slightly taller pieces to kind of gain height faster. So if I try to repeat this to build another tower, maybe I can get with less connections, I could get a lot higher if I change up my tactics or change the way I'm thinking about how to build this tower. I'm going to ask you, Narek, I know you're working on your bridge. How's your bridge going? How far have you made it? Have you made it a distance? Can you measure the distance you've made it?
I've made it like 12 inches.
12 inches. All right. Do you know, can you do inch conversions to millimeters or metric, or do you mostly use inches at school?
It's like 30-ish centimeters.
Yeah. So you're at 8, right? So I'm not going to do any math on the spot, but I do this. That's part of my job every day, right? I work with inches and I work with metric. The reason for that is we're in North America. Some of the materials and tools and things that people use they're American. So learn to use both, right? And it's okay to use either. But we in Canada are part of the metric system. So, and that's usually what's taught in school, but it's good to be familiar with both. So if you made it 8 inches, you kind of beat me, right? But 8 inches that you made it, is it going to support itself? Now, do you have something that you can tell and test to see if your bridge will actually hold its own weight once you've made it your 8 inches? So that's a really good test. You can make it, making a smart shape like a truss, it's going to be able to reach a length. Perfect. As soon as you get to that length, the first test is, will it hold up its own weight? And then secondly, will it hold any extra weight? Because obviously a bridge is made to carry people across, vehicles, etc. So part of your experimentation with making your length is, did the structure I made to make that length also support its weight and then potentially support weight that's going to go on it? And you can try to do this thing that I've done, which is like to separate chairs. I think everybody at home has chairs, and you can separate it in chairs and say, hey, you know what? Yeah, I did make my 8-inch span that I've done here. And I'm sure if you put a little bit more time to it, you can get even further. But also keep in mind that, it has to be able to hold its own weight at some point, right? So,
James,
yes.
I just wanted to talk, when we were talking about materials, sometimes in real life, we do make mistakes. So we need to have some error margin. So sometimes we need a little bit more materials to plan for, so we have enough.
Yeah. So like you said, that's good. It's a really good point. Like I was just doing a quick calculation to say, yeah, I mean, this is how much I need, how I'm thinking, or this is how much I can get to with what I have. But Nadia makes a really good point. Like there's lots of conditions in the real world, and sometimes materials are affected in where they're being used or before they're being used. So there is always a need to have a little extra plan ahead, right? And plan for, like you said, errors and things like that. Things can happen, and nothing's perfect. We always talk about projects that go off schedule, and one of the big reasons they can go off schedule is if someone runs out of material, or maybe not the right material is brought, or amounts are brought to the conditions, right? So that's good. And jump in, anyone, at any time if you have questions, or because we're kind of moving through here pretty quick. I move fast. Yeah, I'll get to that in 1 second. So I know there's not a lot more that I can really discuss on what I've done so far, but I would attempt to try to make some. Did we get anyone else to join? I can't really see. We have 6 participants, that seems. So I'm going to eat one. You know, I've been talking.
That's a very good idea, James.
One extra, right? Okay, so I'm going to change my tactics. I like the idea that Nadia said, you know, you don't have enough material, you're not going to get where you want to go. So I'm going to change my tactics. I'm going to use some of these marshmallows. I'm going to also use pasta, because I think that this guy could be taller in terms of how it's been designed if I just picked lighter materials. Cool pasta, actually. I like this one. It's like a cylinder, but it has a gap in the center. This is actually very similar to a very common structural shape, which would be like a tube, you know, like piping, things like that. But of course, they're made in all kinds of scales. So this is really just like, you know, similar to any other structure shape, just scaled way down. So really, this is becoming more of a scaled down operation here. So if I start with the full length one, I'm gonna do a little fun test. I've given it a footing. I'm gonna give it a top. Can I get, how many of these can I get together? Also, Nara, what kind of, are you using big marshmallows or small marshmallows?
I'm using small marshmallows.
Okay, so have you run into any problems trying to get too many members through one marshmallow? Have you been okay with that? Because that's the thing I was worried.
Like, it's okay, actually.
Not bad? That's good. I think smalls are like the classic challenge, because there's a fun challenge to try to build a tower fast with these kinds of materials. But I was always skeptical if you could stick enough marshmallows into that, especially when you're trying to make a truss, because sometimes the truss has so many materials into one member that there's just not enough space to keep going. So I have this nice little 3-prong floaty iron. He's just standing by itself. But I've chosen this. I don't really know if I'm going to be able to really extend it much taller. So this is actually, it seems like I'm starting from the top. So as I'm designing what I'm designing, I'm saying, this is a nice way to cap it off, because I've got, let me just bring this up the camera. I've got one at the top. Oops, I just fell apart a little bit. And I have 3 at the bottom. So I actually need to say, I wouldn't really be able to continue at the top. I'll have to rethink how I'm going to approach this. But already I can tell, yeah, I'm quickly surpassing my previous one, even with far fewer connections and far fewer materials. But that's just the nature of the materials you choose. You could really get into a much different case depending on what you're choosing. And that's where you'd see with regular structures. You know, if you look at the CN Tower, it's made of concrete, and obviously reinforced concrete. There's steel inside of there to give it some tensional rigidity, because just basic concrete, it can break apart. You put some nice members inside of that, makes it nice and strong. So as I'm building sort of the cap of my tower, I'm saying, well, this is okay, but I have to stabilize it, but I won't be able to build it any taller. So I'm gonna have to treat this like it's the very top. And then I'm gonna be shortening. I'm gonna try to shorten and keep, I don't have to measure this. I'm gonna just measure it by making one length and lining it up and breaking it at the same position. Doing that one more time. Oops. And I've made them not really equivalent. So I'm gonna try to break them one more time. Okay. So I'm gonna build my basis of my tower with a triangle, because as you can tell, I really like triangles. Could do a square. Oops. Oh man, I'm having trouble now. See, if this was the real world and my little structure fell down as I was building it, that would be exactly what Nadi's talking about. I would have just probably lost some quality material and had to restart that part of the build. So, well, especially with practice of what we're doing, it could be very difficult to emulate what we're doing here with our own hands in the real world if it was scaled up to the size of something like the Siena Tower. So I'm going to keep going here. All right, so I think I've made my very simple, and I'll call this just the, oops, no, I'm wrong. It's not holding yet. So let's go further. So I've done this. Man, I'm gonna have to change something up here because this is not working. So one piece keeps falling out in one direction. Trying to get this guy. Did I get it? Did I get it? Okay. So I got my oof, no. Failure again. That's just the nature of the world. Let's see. Okay, so hopefully this stays stable for now. And that's kind of the critical thing with the tower, right? You can build it, but it's got to be stable enough that it will stay. And you know, towers, I mean, we don't usually put weight on them. They're sort of more considered to be supporting their own weight and then raising to a height differently than a bridge. A bridge obviously needs to carry some cargo and things like that. So here, sort of got my very flimsy. I can even bend the spaghetti a little bit. It's not very strong, so, but that's really kind of the point of the tower. But already I've said, okay, how tall have I gotten with like one simple triangular, this is actually a pyramid, right? Well, I've gotten 11 inches, which should be about almost 30 centimeters with a lot less work than something like this. But I know for a fact that's going to take a little bit of weight, and that's actually an interesting foundation. So I could even build one on top of the other. Oh man. Or I could keep going marshmallows if I wanted to and just fix that quickly. So I think if I want to really build a tall tower, I'm going to continue with this guy. I like the result that I'm getting here with the marshmallows and the pasta. It seems to be building tall very fast. So I'll go back to Nara because you made your 8-inch span bridge. Have you been able to extend it any further, or are you stopping? Are you satisfied with 8?
I've extended it to 55 centimeters. I don't know if it's gonna hold,
Nice.
but
Great. Well, that's a good thing. So you're saying I built this thing, and you know, the trick here is if you're saying, you know, I'm using, you can use the thing that I showed, like chairs. You can vary the distance between your chairs to see, does it work here? Does it work here? If you start at the 55 you got, maybe it will. Maybe it'll hold at its own thing, right? If not, then you know you can go, okay, maybe this is actually a good design for only this length. If you apply some weight, like applying the weight is a bit tricky just because of scale. My picture I posted in the email, I tried to make my bridge hold a can of soup, but didn't really design it to hold a can of soup. I said, well, I just kind of want to experiment, you know, and these are small scale tests playing around. So it didn't hold the can on a bridge, but when I put the bridge on the ground to just sit regular, it did hold it. And that was really interesting. I was like, okay, so problem there is that the members were going to fall apart because of all that unsupported area underneath the bridge. But that's really the key with the bridge. It needs to be able to support its weight even when there's nothing underneath it. So what you see in a lot of bridges is you see the bridge not only following this single one truss that we have up here, but it actually would go and sort of expand to many more versions of this and much taller, maybe a couple of layers and a couple of widths. So if you're at 55 centimeters now, that's a good distance. Maybe you need to start building it up a bit, and it'll have actually layers of structure on top of the length that you have to make it a little bit stronger over that size. Yeah, so we're at 5:20. So there's about just 10 minutes left. And I know I've been going off on all these discussions of different kinds of shapes and whatnot. And that's kind of the idea. I just wanted to spend some time with you guys and talk about different materials and different shapes and, put your hands on these materials and see what you can do with them. And if you say, hey, I've made 55 inches, see if it'll hold its weight. If it doesn't, scale it back. And if you really want to try to meet that goal of 55 centimeters, maybe you just need to make it a little wider, a little taller, give that structure a little bit more size and a little bit more support in different directions. So last 10 minutes of this, I wanted to do something fun. So, if we have these individuals here that are working on their little designs and they're saying, you know what, this is cool. So if you would, I'd like to get a little further engagement. And I know that, it's totally fine that you have your camera on. I'm not asking for any visual of this, but if you feel like it, you can send me a photo through a form that I've set up. So I'm going to put this up on the screen. It's QR. If you got your phone, or you can search this the short link. I'm going to double check it works because I was having a little trouble with it. I'm going to put my phone up. But I've designed a form where you can, put your name and talk about what you made and what you think about this discussion about structures and shapes. And you can even share a photo of your thing and also say, hey, mine reached this distance, and make some comments about that. So I'm just going to test this. Let's see if it works. If it doesn't, I will be sending out an email to all registrars of the event, just so you do get access to it later. Just give me one moment. Let's see. Yep, it's working. Cool. So if you have the time and you want to show off your work, use the form, state your name. I'll read out the thing here, and I'll go to it. I'll actually go to it right now. I'll walk us through how this form works. Just give me a moment here. Oops, didn't mean to go back. Sorry about that. Let me just go right here. Sorry, not a Zoom Pro. Sorry about that. Just give me 1 second. I know I can make this work if I can't get my presentation to work properly. Let me just copy this.
While James, you're talking about this, maybe, or looking into this, maybe I can just talk.
Sure, go ahead. Thanks.
James has been talking about, like, let's say, doing something and then testing it a little bit and then seeing that things are not working out and going back to design. And that's very, very normal in any engineering project, actually. We do design, we do a little bit of implementation, we say, and then we do quality testing. And if things are not working well, we go back to design. And that's just part of learning process as well.
Yeah, of course. There's so much experimentation and looking at things, what works, what doesn't. And sometimes it works, but you even learn that through that process of achieving something as a solution, you may even want to, you may learn enough to say, hey, I could have done things different. It could have turned out even better. We talk about this
Exactly.
usually as an engineering, like Nadia's saying, open-ended solutions.
Yeah.
Ways to solve problems that there's not really the right or wrong way to do it, but there's different ways to do it. And maybe the first time you solve a problem, it's done one way, but maybe the next time you solve it, you do it better, faster, maybe cheaper when we consider money, which is always the thing when we do engineering, costs of things. So yeah, there's tons of opportunities to improve and learn. Excuse me, sorry about that. Let me just get this.
And sometimes we also try to do some lab testing as well before going to real implementation. Again, we are all humans, and we know sometimes our design impacts also humans. So we have a responsibility towards them, but we got to learn also as an engineer, as a human, before we can do all those.
Exactly. And that's part of what I said in the beginning too, like we're doing things for the benefit of society in a lot of cases. Sometimes it doesn't realize when you get into engineering being that's what it is about, but when you start to interact with more people and you see the impact of what you do, you can understand that it's affecting not only yourself or people around you, but usually a lot more than the people around you. And to a lot of people, it's very important as being an engineer. So now look at this form up. Sorry for the problem. So I put this simple form together, and it's pretty quick. You know, you put your name. Like I said, I'll just say that I chose tower because that's kind of what I was doing in the second half. And then I'll just put my name and say, so what height did I receive? So I measured before. I said 11 inches, or if I want to do conversion, do that on my head, it'll be roughly, again, if you want to do it correct, look up the calculation to kind of give it one way, or just choose one. You know, measuring is still measuring, and you don't always need to convert between systems, right? So I'll say 11 inches, and then I say like learn from event. I said, let me see here. What did I learn? I learned, I don't know what I learned.
It was tasty.
I learned
right?
that an art can build a really long span of a bridge very fast, much faster than I can.
Exactly. And the
job.
candy was really tasty. I think that's the learning experience too.
Yeah, that is true. And I learned that my triangular tower thing wasn't exactly what I was expecting it to be, right? So just leave a little blurb. It doesn't have to be very long if you choose. And then the last part is if you want to show what you did, or maybe how it's set up to work, you can actually upload a picture. So browse and then load a picture kind of thing, but I won't do that right now. You hit submit, it'll just say thanks for submitting event, and hopefully we get some submissions, and I can send around like a little showcase of what people have been able to do, and show off some of your cool designs. And anyway, after beyond this, let me go back to the presentation. So let's go to back here. So we'll pass that. If, like I said, if you didn't get a chance to get the link, I will send an email around to those who have signed up for this Zoom event. So feel free, and don't worry if you didn't get to it right away. And that pretty much takes us to the end. I just want to say thank you for those who joined us, and thank you to the National Engineering Month team who was able to give us this time slot to reach out and get involved with you, fine people that have joined us. And I was just going to also say we have tons of partners, thanks to our sponsors that are helping and National Engineering team administer all of these seminars, tons of seminars this year. And if you didn't get to enjoy any other ones other than this one, look forward to next year and try to get involved in more events, because they have multiple per day on the weekend, lots of opportunities to learn different things. If not something simple like we're talking about today, maybe you're interested in a more professional style thing done by a different engineer doing something more related to career path, something like that, or just a topic in general. There's lots of cool things out there. And the last thing I want to do is I have to, by request, I'm going to stop my screen share, and I'm going to activate the poll. And that's a poll done by the team. So there is a poll up there, and if you'd like to take part, please, I'll read through it as we go. And it says, if you want to know more what you think, please check all that apply. Multiple choices are fine. So if I learned or deepened new knowledge and skills or values, learning from this event will be helpful to me, or would I attend another event for NEM Ontario in the future? So take part in the poll if you can. I know the organizers appreciate it. And again, thank you for joining us. Hope to see a submission or two if I can. That would be great. And again, no rush on the submission. I'll check into it after some time, maybe over the weekend. If anyone wants to spend a little extra time doing something, or taking some ideas back and having some other solutions to solve. So, any words from anyone? Does anyone have any questions or last minute comments?
Thanks, James. I think I also learned a lot of new things here.
Don't be so modest, Nadia. I know you know tons, but thank you. I appreciate your kind.
Nothing with bridges, trust me.
Oh, come on.
But yeah, thank you.
Thank you. All right. And I think the meeting is about to end and roll into the next one. So appreciate everybody. Have a great weekend, and thanks for joining the event.
Thanks, James. Have a nice weekend, everybody.